in this problem, we want to integrate 4y ds. This time s is a portion of this guy, so that should be a cylinder, oriented a little bit differently than normal. A vanilla cylinder, like a circular cylinder, not like a parabolic cylinder or any of the other cylinders you talked about in Math 126. And it's between these two planes. So what is going on? This is a cylinder of radius 2. Okay, so if that's the x, y, and z, we go into the yz plane and we draw a circle of radius 2, and then we extend that forever, allowing x to be any value. And now between x equals 0, so we're cutting it off here at this plane, and then we're cutting it off here. What's that? Okay, that's 2. If we go in the xz plane and we draw the line x plus z equals 3, that's got to go through the value 3 on both these axes. So it's actually like that, and then we extend that in the y direction forever. Okay, so it's cutting this cylinder. A plane will cut a cylinder in a kind of an ellipse shape. So the part of the cylinder we want then is that thing. And also behind. Okay, so that's what's going on. Let's see if we can parameterize the cylinder. So R, let's see, what happens? So in the yz coordinates, because y squared plus z squared is always 4, so that's a circle of radius 2, so maybe we want to parameterize it as a circle of radius 2. So that's only one parameter, and x can be anything it wants on the cylinder, so that is a reasonable parameterization of the cylinder. X is anything it wants to be, and then theta describes what happens to y and z. Okay, so let's find the partial derivatives. Okay, well this one's easy, 1, 0, 0, and our theta is 0, negative 2 sine theta, comma 2 cosine theta. Okay, so then the cross product, r x cross r theta, I, j, k, we have 1, 0, 0, 0, negative 2 sine theta, 2 cosine theta. Okay, so then we get 0, comma, negative 2 cosine theta, comma, negative 2 sine theta. So, and without doing square roots or anything, because we have a cosine theta and a sine theta there, I can tell that the magnitude of this is going to be 2. You can certainly do square roots and calculate it, but if you have a little bit of experience with circles, which we do at this point, you can tell the magnitude is going to be 2. Okay, now we need, let's see, 4y, right? Okay, so the integral, y is 2 cosine theta, so 4 times 2 cosine theta is 8 cosine theta, and then another 2, so this is 16 cosine theta. And then we need to figure out x and theta in this weird cylindrical region. So theta tells you how far around the circle. We're going to go all the way around. So theta is going to go from 0 to 2 pi. And then for each value of theta, we actually get this x line on the cylinder. And x starts at 0 and goes to this plane, which is actually x equals 3 minus z is another way to write this. But z is 2 sine theta. So this is x equals 3 minus 2 sine theta. Okay, so those are the bounds. Theta goes from 0 to 2 pi, and x goes from 0 to 3 minus 2 sine theta. Okay, so let's work that out quickly. Let's see, this is 16 sine theta. No, 16, Right, we're integrating with respect to x first. 16 cosine theta times x, going from 0 to 3 minus 2 sine theta. Still having to integrate with respect to theta later. Plugging in those bounds, we get basically 48 cosine theta minus 2 sine theta times cosine theta is sine 2 theta. So an easy way to write this would be 16 sine 2 theta. And then plugging in 0 gives you 0. Okay, now we're going to integrate that with respect to theta. So we get, and maybe if you've seen this before, you're already suspecting the answer is going to be 0. But let's do it. Plus 8 cosine 2 theta, and then we're going to be plugging in 0 and 2 pi. And of course, all the cosine values are 1, but we're subtracting off the same value. So yeah, you do end up with 0. Feel free to check that. Does that make sense? We might get a little bit scared when the answer is 0. Let's go back and look at our region. We were integrating 4y over this part of the cylinder. This part of the cylinder is symmetric with respect to the xz plane. We have equal amounts of positive and negative y values. So yeah, it's okay that over that cylinder, the integral of 4y is 0.